Hello students, welcome to my Tau Fusion channel of YouTube. Now, last day's problems, we have discussed a problem which is placed on the fluid mechanics, and we have discussed many other forms of the fluid mechanics and how we are using the boundless theorem as well as the equation of continuity. Now, today we are going to discuss a particular problems where you'll find that whenever we are using the Bernoulli's theorem in a particular problem, so in that case, we will see that there are multiple holes may present in a particular jar. For example, if you consider this jar which is filled with a particular liquid, there are two holes are present in one side of the jar. One is Q and another one is P. And the distance of the point Q is certain distance H2, H1, sorry, and that is from the top level of the liquid, that is from the surface of the liquid, and the point P is Q present at a height H2 from the bottom of the liquid level. So what exactly it is mentioned, let's see. Let's read the problem first. It is mentioned in a cylindrical water tank. There are two small holes Q and P on the wall at a depth H1 from the upper level of water. That means this is the H1 from the upper level of water is this. So from that H1 level in the downward directions, when at a depth H1, a hole is created or a hole is present, that is Q, through which water is coming out, and at a depth P another hole is present which is at a height H2 from the bottom of the liquid. Now what is mentioned, the water which is coming out from this particular portion, here mentioned that water coming out from the both holes strike the ground at the same point. So that means we can consider the water which is coming out from this particular two holes is basically reaching to the ground at the same level. So this particular distance is same for both the liquids. Now what exactly we have to find out? We have to find out the height of these two holes from that is from the top of the liquid level as well as from the bottom of the liquid level. So we have to find out the ratio between H1 and H2. So this is the exactly we have to find out over here. Now if we consider, suppose if we just draw a portion like this. Now suppose in this case if we draw a cylinder and we just check it how we can do this particular type of problem. So this is particularly a cylinder. Now we have draw this particular cylinder over here. I'm just drawing the base level of the cylinder, and this particular point we can consider as the point Q. So this yellow color point we are considered as Q, and this is point P. Now as per the given information, this height of point Q and this is point P, so this height is H1 and this height on the point P from the base level is H2. So we know that the water is coming out from this level. It is reaching to a height, suppose reaching to the base on the ground, that is at the point suppose A. And here also the water level which is coming out from this particular point Q. So you see that this is also reaching to the height, reaching to the point that is A. So both the water basically falling into the ground at the same point. Now what exactly we are going to do over it? We are going to use the Bernoulli's theorem in these 2 points. Because suppose if we consider the velocity of water which is coming from this particular point, suppose if we consider this is VQ. So we are considering VQ, no, V2, and this we consider as V1 suppose. Now these are the two velocities of the liquid because this jar is filled up with the liquid. So we consider V1 and V2 is the liquid which is coming out from this particular hole. The velocity of the liquid is V1 and the velocity of the liquid is V2 which is coming out from the point Q. So velocity of efflux you can consider at the point Q is V2 and velocity of efflux at the point P is V1. That we can consider. Now what we have to do, you just check. Now, in this case, what exactly will happen over here? The first and foremost thing is the total height of this entire liquid column that we consider as the H. So that we are considering is the total height of the liquid column. So for the first case, if we just consider for the first case, that means here we see that the range. So we can say that the range of liquid which is coming out from point Q, if we say this is R1, say, range means I am talking about this particular range, that is R1. And similarly, the range of the range of liquid which is coming out from the point P, and suppose this is R2. So we can say, as per the given condition, that R1 is equal to R2 is equal to RC. So we can say this is the range is basically same. And it is already mentioned in the given problem that the water which is coming out from both the holes strike the ground at the same point. So we can consider these 2 points are basically reflecting through which the water is coming outside, and from the point P, the velocity of efflux is V1, and for point Q, the velocity of efflux is V2. So now what to do? If we apply the Bernoulli's theorem, so first we see what exactly we mean by, because here if we just consider this is the two velocities, so we can say for this, that particular range for R1, we can say that is V1 into T1. So we can say this is the V1 into T1. And for these things, we can write down V2 into T2. So now question is, what is T1 and what is T2? Now T1 basically the time taken by the velocity of efflux, that the liquid which is coming out from the point Q, that means द पॉइंट जो Q है वहां से जो लिक्विड निकल रहा है, जो ऐसे करके गिर रहा है, तो इसी पॉइंट से जो लिक्विड ऐसे करके पॉइंट ए जो ग्राउंड में है वहां पर जा रहा है, तो उसका टाइम कितना लगा ये गिरने में. That means after releasing from the point Q, how much time is taken by the liquid to reach to the ground A, that is T1. So T1 basically the time taken by the liquid to reach ground, that is the T1. And if you move to the T2, that is the time taken, that you can say the time taken by the liquid to reach ground. Okay, so that is basically the 2 points. Now we know as R1 is equal to R2, because this is R2, this is R1. So you can say these things that R1 and R2, these two are basically same, because both the liquids are reaching to the same point, that is A. So we can say these things that V1 into T1 is equal to V2 into T2. That we can say over, and that is our basically equation number 1. That is the equation number 1 we have got from here. Now what you will do, this is the first equation. Now we know that this V2, that is basically what? That is basically velocity of efflux. That we say the velocity of efflux, and we know the velocity of efflux is root over of 2gh1. So that is basically the velocity of efflux. If you consider the V2, that is the velocity of efflux is at the point Q is above. So if you consider V1, so this particular V1 is coming down to how much at the point P. So if you take the point P, so that is basically the velocity of efflux at point P. And this is basically the velocity of efflux at point Q. So this is the velocity of efflux at the point Q, and this is the velocity of efflux at the point P. So we can consider this is come down to root over of 2 into G into capital H minus this, means that particular distance. So it comes down to H minus H2. So this is equation number 2, and this is equation number 3. So we have got these two equations over here. कारण वेलोसिटी ऑफ इफ्लक्स वी नो दिस वेरी वेल, जो ऐसी वेलोसिटी ऑफ इफ्लक्स निकलता है जो जहां पर लिक्विड हॉरिजॉन्टली जा रहा है, तो इसी पॉइंट में जो वेलोसिटी ऑफ इफ्लक्स होगा दैट इज रूट ओवर 2g1, और ये पॉइंट जो है दैट इज पॉइंट P में जो वेलोसिटी ऑफ इफ्लक्स होगा दैट विल बी रूट ओवर ऑफ दिस हाइट. सो हाउ मच दिस हाइट इज, दैट इज टोटल हाइट इज h. So h से अगर स्मॉल h2 subtract कर दो, तो this particular height which will come, that height will be this. I am talking about this height. So this height will be capital H minus h2. So this particular height we have considered over here. Clear? So now T1, that is the time once we are considering, that means for the first liquid which is ejected from the point Q, that means point Q से जो liquid होके ऐसा उसका time था T1. So T1 time is taken by the liquid to reach from the point Q to the ground. So this T1 value will come down to how much? So this T1 will come down to 2 into 2 into H minus H1, this one by G. So T1 is the time of fall of the water stream from the point Q. So we can write down this, ultimately come down to this by this. How much high it is, because you see that how much distance is covered by this. Similarly T2 कितना होगा? T2 का जो value होगा, that will be root over of 2 into H2 by G. So that is the value. So this is equation number 4 and this is equation number 5. सो आपके पास टोटल 4 इक्वेशन आ गए इसी प्रॉब्लम से. So now you have got 4 equation, that is number 1 equation is this, number 2 equation is this, the velocity of efflux at the point Q. So this is the point Q and this is the velocity of efflux at the point P. So you have got this equation, and time taken by T1, that means liquid to reach from the point Q to the ground, that means इस point को चलो मान लेते A point. सो क्यू से पॉइंट लेकर ए तक जाने के लिए जो कितना टाइम लगा, दैट इज T1, और पी पॉइंट से स्टार्ट करके लिक्विड को ए पॉइंट पर आने में जितना टाइम लगा, दैट इज T2. सो वी कैन कंसिडर दिस T2 इज इक्वल टू रूट ओवर 2 इंटू H2 बाई G. तो अभी क्या करना है हमको? सो वी यूज दिस एंटायर थिंग्स. ये जो T2 T1 का वैल्यू मिला, हाँ, और ये जो V1 का V2 का जो वैल्यू मिला था, सो बेसिकली विल जस्ट पुट इट इन दिस फर्स्ट इक्वेशंस. सो हमको जो करना है यहाँ पर बेसिकली ये जो वैल्यू था, सो चलो मान लेते इसका वैल्यू हमने वेलोसिटी ऑफ इफ्लक्स जो पकड़े थे, दैट इज 2 इंटू रूट ओवर GH1 पकड़ा था. सो इसको हम V2 करके लिखा था, तो इसको हमने एज पर द प्रॉब्लम्स इजी अंडरस्टैंडिंग के लिए इसको T2 बना देते और इसको T1 बना देते, तब आसान होगा, नहीं तो कॉम्प्लिकेसी आ जाएगा. सो व्हाट एग्जैक्टली वी आर डूइंग ओवर हियर, इसको T1 ले लेते हैं, that is basically the time taken by the liquid, time taken by liquid to reach point A, to reach point A from point P. और T2 जो है, that is basically the time taken by liquid, time taken by liquid to reach point A from point Q. Correct? So this is the way we can justify. Now what exactly we'll do, ये जो value मेरे को मिला था V2 and T2, so these two values we'll put over here. So चलो यहाँ पर उसको बैठा देते, ठीक है ना. तो इस जगह के लिए हमने ऐसे करके कर सकते हैं. सो यहाँ पर लिखा है R1 V1, मैंने जहां पर जो चीज लिखा है तो हमको वो बैठा देना चाहिए. सो हम क्या कर रहे हैं, बेसिकली वी आर जस्ट पुटिंग इट, दैट इज H माइनस H1, दैट इज इक्वल टू इंटू H1 होगा, और यहाँ पर जो होगा H माइनस H2, दैट इज कम डाउन टू H2, बिकॉज हमारा पास ये जो टोटल चीज है इसको हम इसी से मल्टीप्लाई कर देते हैं, दिस टू आर मल्टीप्लाई. सो इफ आई मल्टीप्लाई दिस टू थिंग्स, हाउ मच इट कम डाउन टू V1 इंटू T1. सो उसका वैल्यू कितना होगा, 2G इंटू कैपिटल H माइनस स्मॉल H2 इंटू रूट ओवर ऑफ 2 इंटू H2 बाई G. सो G कट दो तो अल्टीमेटली कितना आ जाएगा, सो अल्टीमेटली इट कम डाउन टू 4 इंटू H माइनस H2 इंटू H2, ये आ जाएगा, दैट इज योर V1 इंटू T1 हो गया. सो सिमिलरली अगर V2 इंटू T2 करोगे तो कितना होगा, सो तुम्हारा V2 इंटू T2 अगर करोगे तो उसका वैल्यू होगा 2GH1, और उसको तुम इससे से मल्टीप्लाई करो, दैट इज 2 इंटू H माइनस H1 डिवाइडेड बाई रूट ओवर ऑफ G. तो G कट दिया, यहाँ पर 2 इंटू 2 तब मैंने इट कम डाउन टू रूट ओवर 4 इंटू H1 इंटू H माइनस H1. तो ये जो मिला है तुम्हारा और ये जो मिला है, बेसिकली ये दोनों चीज को हम लोग इक्वेट कर सकते हैं. व्हाई वी कैन इक्वेट दिस थिंग्स, बिकॉज V1 T1 और ये जो मिला है दैट इज V2 T2. सो V2 T2 का वैल्यू ये है. सो दीज टू बेसिकली यू कैन इक्वेट. सो व्हाट यू कैन डू, these two equations which you have got over here and these two equation you just equate and you place over here. सो इफ यू प्लेस दिस इक्वेशन ओवर हियर कितना आएगा? सो तुम्हारा जो इक्वेशन आएगा तो ये हो जाएगा, क्योंकि यहाँ से 4 जो है वो कट जाता है। सो कट जाने के बाद तुम अगर स्क्वायर कर दो तो इसको स्क्वायर करने से कितना होता है? इट कम डाउन टू h माइनस h1, इसी तरीके का एक फॉर्म में आ जाता है। तो इसको हम सिंप्लीफाई कर लेते हैं। तो इफ यू सिंप्लीफाई दिस पर्टिकुलर फॉर्म्स देन व्हाट विल हैपन? नाउ यू जस्ट चेक ओवर दिस, it comes down to h into h1 minus h1 square, and here it will be h into h2 minus h2 square. तो इसको इधर लेके चला, तो if you take it to this side then what will happen? Then it will be h1 square minus h2 square एक आएगा, और इस साइड में हो जाएगा that is plus into h into h2, इसके साथ a माइनस हो जाएगा, that means h into h1 is equal to 0, ये आ जाएगा। अभी इसको एक बार कॉमन ले लेते, दैट मीन्स h1 into h2 is equal to h1 minus h2. So we have split into factorize, that is a square minus b square form, and here we just see how it comes. এখানে you can take h common, so it comes down to h1 minus h2 is equal to 0. So after that you just take h1 minus h2 and your entire phenomena will be h1 plus h2 minus h is equal to 0. तो यहां से तुम देख सकते हो h1 माइनस h2 कैन नॉट बी इक्वल टू 0। अच्छा, हो सकते नहीं हो सकते वो तो बाद में चलेगा है। एक वैल्यू जो आ रहा है दैट इज कैपिटल H इज इक्वल टू h1 प्लस h2, ये भी निकल रहा है, सॉरी इसको h1 आइदर इट विल बी 0, सो आइदर दिस विल बी 0 और h इज इक्वल टू h1 प्लस h2। बट हमको पता है h इज इक्वल टू h1 प्लस h2 कभी हो नहीं सकता। क्यों हो नहीं सकता? बिकॉज द रीजन इज वेरी सिंपल, अगर h का वैल्यू पूरा है तो h1 का वैल्यू तो इतना दूर तक है यार, h2 दिस, तो अगर h इज इक्वल टू h1 प्लस h2 होता तो इसका वैल्यू कहां जाएगा? दैट मीन्स इफ h इज इक्वल टू h1 प्लस h2, इफ इट इज ट्रू, तो ये अगर करेक्ट है तो हमारा P पॉइंट एंड Q पॉइंट ये दोनों जो पॉइंट है वो एक के ऊपर दूसरा आ जाएगा। That means between P and Q there will be no distance remain. So P and Q point this will be overlap with each other. But that has not happened क्योंकि Q का थोड़ा नीचे P point है. So once the Q point is far below और थोड़ा नीचे है, that means between Q and P there is certain distance remain. So we cannot say that H is equal to h1 प्लस h2, ये हो नहीं सकता। दैट मीन्स h1 इज इक्वल टू h2 ऐसा ही होगा। सो वी कैन से h1 बाई h2 दिस रेशियो विल बी 1, क्योंकि इसको नमा दो, सो h1 बाई h2 अल्टीमेटली कम डाउन टू 1। सो इफ यू जस्ट टेक इनटू द ऑप्शंस ओवर हियर, तो यहाँ पर ऑप्शंस ए में देखा जाए तो दिस ऑप्शन ए इज बेसिकली शोइंग a is equal to 1. So here you can say that option 1 is the correct option over here. So if you just look into the problems, so how we have used it, basically a range जो है, a range का फॉर्मूला हमने यूज किए और दोनों रेंज जो इक्वल बता दिया उसको पहले हमने इक्वेट कर दिया, एंड देन आई हैव फाइंड आउट द इंडिविजुअल velocity of f flux for these 2 points, one is q and another one is p। पहले इसका वेलोसिटी ऑफ इफ्लक्स निकाल दिया, उसके बाद इसका वेलोसिटी ऑफ इफ्लक्स निकाल दिया, और दोनों को वेलोसिटी को हम अलग अलग करके दोनों इक्वेशन में बांट दिया। वन इज दिस वन, दैट इज फॉर द पॉइंट Q एंड दैट इज फॉर पॉइंट P। उसके बाद पॉइंट Q से नीचे गिरने के लिए कितना टाइम लग रहा है उसको हमने फाइंड आउट किया, और पॉइंट P से लिक्विड को गिरने के लिए ऑन द सेम पॉइंट ऑन द ग्राउंड, दैट मीन्स फ्रॉम पॉइंट Q से लेकर A तक और पॉइंट P से लेकर A तक। सो इफ द लिक्विड हैज फॉलन फ्रॉम द पॉइंट Q एज वेल एज फ्रॉम द पॉइंट P, हाउ मच टाइम इट हैज टेकन टू रीच द सेम पॉइंट at A on the ground, that we have calculated by using this particular principle. So once we have used this particular principle, we have got these things, that is T2 is equal to this much. And how we have got it? Simple thing, we know that H minus small h1 is equal to half G into T2 square. So here by using this formula you can get 2 into H minus h1 by G is equal to T2 square. So if you get it, then you can get T2 is equal to root over of 2 into H minus H1 by G. So this is the way we have calculated T2. And similar manner, we have also calculated T1 because we know this is for T1. So how much distance it is traveling? Now H minus H1. So here in this case we have got it. In the next case it is H2. So we can say H2 is equal to half into GT square. That is for second velocity, that is V1. So we can say 2 into H2 divided by G root over of this, that is come down to T1. So this is the way two time frame, the time taken by the liquid to reach to the ground from the point P as well as from the point Q, that we have calculated separately. Then the time which you have got from here, that we have multiplied with the corresponding velocity over here. So once you have multiplied with the corresponding velocity, because we know V1 and we know V2, so these two velocities are known to me. So if I multiply T2 with the V2, that means this way, and if I multiply T1 with the V1 this way, so ultimately in this equation if you plot, we will get the result. एंड आफ्टर दैट जस्ट सिंप्लीफिकेशन ही बचा हुआ है. तो बेसिकली इसी प्रॉब्लम में तीन चार कॉन्सेप्ट, एक तो मोशन का, वर्टिकल मोशन का कॉन्सेप्ट यूज किया, वेलोसिटी ऑफ रिफ्लक्स इफ्लक्स का कॉन्सेप्ट यूज किया, एंड अनदर मोस्ट इंपॉर्टेंट कॉन्सेप्ट व्हिच यू हैव यूज्ड, दैट इज इन द हॉरिजॉन्टल रेंज का जो रेंज जो होता है उसको दोनों लिक्विड के लिए सेम है. सो हाउ वी हैव यूटिलाइज इट, दैट इज इंपॉर्टेंट. So if you find this is interesting, so you just make some comments and subscribe this particular channel, and make the comments that whether you want to listen this kind of problems, whether you want to estimate your standards by using this kind of problem in the IITJEE or JEE or not. So if it be really fruitful to you, so please do subscribe and like this channel. Thank you.